in this video, I'm going to show you how to calculate the percent composition of propane, which propane is C3H8. So in other words, I'm asking you, what is the percentage of carbon versus the percentage of hydrogen in this formula of propane? Now, the formula that we're going to be using is one of these, and these formulas basically represent the exact same thing. It's just one is set up as more of a ratio type of formula, and the other is set up as a more traditional percent formula. You're just going to take the mass of the element that you're dealing with first times the number of atoms present in the formula and divide that number by its molar mass and multiply by 100. So let me go ahead and show you how I'm going to do that with propane. I notice in the formula there are 3 carbons in the formula, and I'm going to take 3 and multiply it by the mass of 1 carbon atom. I'm using the periodic table that we use in class, and so the total mass of carbon, because there's 3 of them, is 36.033 grams per mole. So this is in 1 mole of propane. The total mass of hydrogen in 1 mole of propane is 8.064 grams per mole. I considered the fact that there are 8 hydrogens in the formula, and each hydrogen has a mass of 1.008 grams. Now I'm going to use these individual masses of each element to calculate the percentage, and all percentages, doesn't matter what content area you're talking about, percentages are always parts out of a whole. This is the part of carbon, this is a part of hydrogen, and here's the whole. The whole is represented by the molar mass. The molar mass is the sum of the individual parts. So let me show you how I'm going to do a percent composition calculation. To calculate the percent composition of carbon, I'm going to take that number I calculated, 36.033 grams per mole. This represents 3 moles of carbon. And I'm going to divide it by the molar mass. So the part is carbon, the whole is propane, and I'm going to multiply that value by 100, and here's the number I get. Now I am trying to be super proper about following my significant figures rules. When I divide 5 sig figs by 5 sig figs, I want to end up with a number with 5 sig figs. I'm being super proper here. Now to calculate the percent of hydrogen in the formula, I'm going to follow the same steps, except my numerator value is going to represent the total mass of hydrogen in 1 mole of propane. So here is the total mass of hydrogen in 1 mole of propane, and this is the total mass, molar mass of propane, and so I'm talking about the part out of the whole, times 100, of course. Again, I'm being super proper with my significant figures, and I am dividing a number with 4 significant figures, 1, 2, 3, 4, by a number with 5 significant figures, 1, 2, 3, 4, 5, and I always round my answer to the value with the lowest number of significant figures, so that's why I have 18.29%. Now, while this is the final answer, this is the percent of carbon and this is the percent of hydrogen, do realize that all percentages add up to 100%. So this green value plus this green value should pretty much equal 100%. And if I wanted to get hydrogen's percentage without doing all of this calculation, I really could just subtract this from 100. All right, so that's an example of how to calculate the percent composition.